Are you comfortable with this screen? I'm waiting for your reply. See, there's some solution. Here in solution, concentration term is clear, right? Okay. So I'm going to start Henry's law. Okay. So see, what is Henry's law? According to Henry's law, partial pressure of gas directly proportional to the mole fraction of gas on liquid. Partial pressure of gas on liquid directly proportional to the mole fraction of gas in liquid, and this proportionality sign is removed by putting a constant K. That is Henry's constant. This is Henry's constant. Now see, what I want to tell you is that you have seen a bottle of cold drink in which when we open the bottle, there is some gas. This is liquid. This is whole liquid and there is gas filled. Now this gas is applying some pressure on this liquid. This partial pressure of gas applying on the liquid will be directly proportional to the mole fraction of gas. Mole fraction of gas on the liquid. To remove this proportionality sign, we have Kh, that is Henry's constant. Are you getting my point? And see, this Henry's constant depends on solvent. And if we have a graph to plot between pressure, partial pressure of gas and mole fraction of gas, since they are proportional, so the graph will be a straight line. Got it? So this is what Henry's law says. If you want to write a statement about it, we can write a statement. Okay, 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 okay. Please write it. Let me write the statement about it. According to this law, the partial pressure of the gas in vapor phase is proportional to the mole fraction of the gas. Let me know when you are done with this. This Kh, Henry's constant depends on solvent. Then first write it and then let me. Now see, yes, I will just write it. See, there is a topic that is solubility. Solubility is the process or a phenomena. Basically, it is the amount of solute that dissolved or soluble in solvent, that is called solubility, and this solubility depends on, we can write factors on which solubility depends. The first factor is basically temperature, and it is very important. It is very important. For temperature, basically it depends on the process, whether it is endothermic or exothermic. Endothermic or exothermic. See, endothermic, that means delta H positive. Delta H positive. So basically, you can see delta H positive or endothermic is the process in which heat is required. Heat is required for the process. So if you are going to dissolve something, that process is endothermic, and that means basically heat is required in endothermic process. If temperature is increasing, and you can see heat is required, and if you are going to increase the temperature, heat is indirectly given to the system. That's why solubility here increases. Solubility increases. Also, if you are going for exothermic process, exothermic, that means delta H is equal to negative, change in enthalpy, and heat is given out the system. Heat is given out. That means basically during this process, heat is given out of the system. That means basically heat energy is already here too much. That's why it is releasing heat. And in this case, if you are going to increase the temperature, that means indirectly you are going to give it heat energy that it doesn't want, because it has already too much heat energy. That's why it is releasing some heat. So solubility here decreases. Solubility here decreases. One more important point is that aquatic animals, its application basically, aquatic animals, then we will come to the application of Henry's law. Aquatic animals are more comfortable, more comfortable in winter, you can say in winter, or cold water than summer or hot water or warm water, because the dissolution of oxygen in water is exothermic process. That means it is already releasing heat, and in summer temperature increases. That temperature, due to that temperature, heat energy is given to that process that it doesn't require because it has already too much heat. So dissolution of oxygen into water is not that much as compared to winter or cold water. Are you getting my point? Please write this. Dissolution of oxygen in water I'm talking about for aquatic animals. Very good. Now see, we have application of Henry's law. There are a lot of applications of Henry's law. The first is basically CO2 to increase the solubility of carbon dioxide in soft drink by increasing its pressure. Soft drinks or soda or soda water is filled with high pressure. High pressure. Now the next, scuba divers scuba divers also use this in case of the dissolution of oxygen for breathing. Basically there is higher concentration of dissolved gases, so at high pressure it requires Henry's application is required to get a comfortable breath. We can write a point about this. These are cope with high concentrations of dissolved gases while breathing at high pressure underwater. So basically this increased pressure increases the solubility of atmospheric gases in blood. Are you getting my point? So basically when divers comes down on the come on the sphere, the pressure decreases. And now this dissolved gases leads to the formation of nitrogen gas or nitrogen in the blood. And due to this nitrogen bubble on in the blood leads to the formation of basically blocks capillaries and creates a medical condition. Are you getting my point? And very danger and painful. So let me know when you are done with this. Also, there are a lot of other applications you can read it. Now, see, vapor pressure of two volatile liquids. Vapor pressure of two volatile liquids. So basically, we have two containers in which A, 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 A is present, which is volatile. Another container in which B is present. B is basically solute you can take. And now if you are going to mix this in a bigger container, it will be like A, B, A, B. Also A, B, A, B. Now you can see when A is pure, I'm going to denote it by P naught A. When B is pure, I'm going to denote it by P naught B. This P naught A represents pure vapor pressure. We can write volatile substance is the one which gives vapor pressure. Non-volatile is the one which does not have vapor pressure. Got it? And volatility depends on the compound, in which type of compound it is. Some are more volatile, some are less volatile. So basically this is vapor pressure of pure liquid A. Pure liquid A. This is vapor pressure of pure liquid B. Pure liquid B. Now when they mix with each other, they will be known as PA and PB. PA is partial pressure of A, partial pressure of A, and PB is partial pressure of B, partial pressure of B. First, you are going to write this and then let me know. There will be Raoult's law. So here comes the Raoult's law. So first I'm going to write the Raoult's law and then I will write its mathematical equation. So basically what Raoult's law says, according to this law, write with me, according to this law, the partial vapor pressure of each component of the solution is directly proportional to the mole fraction of that compound, mole fraction of that component present in the solution, present in the solution. Please write it and let me know when you are done with this. Now see, what does this statement say? Partial pressure of each component, we took A and B. So I'm going to talk about A first. So basically, partial pressure of A directly proportional to mole fraction of A. To remove this proportionality sign, I'm going to write P naught A, pure vapor pressure of A. This is the formula from Raoult's law. In the same way, PB directly proportional to zeta B, that is mole fraction of B, and PB, partial pressure of B, will be equal to pure vapor pressure of B into mole fraction of B. Now the next point, which is very important, you know that from class 11th, Dalton's law, total pressure is equal to sum of all individual pressure, sum of all individual pressure. So if we are going to calculate PT, so what is the sum of all individual partial pressure? Partial pressure. Now, since we have only two components there, so partial pressure of A plus partial of pressure of B, or we can write at the place of PA, P naught A zeta A plus P naught B zeta B. Please write it. Yes, gas in liquid. So I'm going to give you a question on this. Done. Now I'm going to give you a question. 7.8 gram of benzene. Do you know the chemical formula of benzene? Mixed in 9.2 gram of toluene. Do you know chemical formula of toluene? What about this? Calculate partial pressure of benzene and toluene. Also Total pressure of solution. Total pressure of solution. If P naught E, that means vapor pressure, P naught B basically, vapor pressure of pure benzene is equal to 400 mmHg, and P naught T, that means vapor pressure of pure toluene is equal to 300 mmHg. C6H5, basically this is a C6H5CH3. This is the formula of toluene, and benzene, you know, C6H6. Please do this question. How to solve? Very good question. No problem. See, and it's a very important topic. We need to calculate partial pressure of benzene. So partial pressure of benzene will have a formula, pure pressure of benzene into mole fraction of benzene. And partial pressure of toluene will have a formula, pure pressure of toluene and mole fraction of toluene. Now see, this is how is it is how much is it is. Now you can see that P naught B is given, pure vapor pressure of benzene, and pure vapor pressure of toluene is also given. What you need to calculate is mole fraction of benzene and mole fraction of toluene, and put the value here. It is given, and just calculate it, PB and PT. Can you calculate the mole fraction? Yes or no? Okay, see, if you are going to calculate the mole fraction of benzene, this will have a formula, number of moles of benzene upon number of moles of benzene plus number of moles of toluene. Can you tell me the number of moles of benzene? Yes or no? Or I should help you? Given mass upon molar mass. Very good. So number of moles of benzene will have a given mass 7.8, and molar mass, if you are going to calculate what it will be, it will be 0.1 mole, 0.1 mole. Again, if you are going to calculate the number of toluenes, number of moles of toluenes, given mass that is 9.2, and the molar mass, if you are going to calculate it, you can see this will also be 0.1. Now going to put the value here, mole fraction 0.1 plus 0.1, that will be equal to 0. Darshan, are you there? I just got disconnected. So you can see this will be cancelled. So mole fraction of benzene will be 1/2. So now what you need to do is PB is P naught B has a value 400 and mole fraction of benzene is 1/2. So it will have a value 200 mmHg. Can you explain the molar mass part? So see, okay, no problem. See, if you are going to calculate the number of moles of benzene, which has a formula given mass upon molar mass, given mass C6H6. Now, one carbon has a atomic mass 12. Here, 6 carbon is there. 12 into 6 plus 1 hydrogen has a atomic mass 1 and 6 hydrogen are there. So you are going to multiply it by 6. So 72 plus 6, that will be 78. That's why I divided it by 78. Darshan, am I audible clearly? Yes, yes. Darshan, are you there? So, do you know how I just calculated this molar mass concept? Clear? This there will be definitely a question on this. Okay, wait a minute. I'm going to explain it again. Let me know if I'm lagging in between. Okay. Yes, why not? See, Darshan. I'm going to just erase this and again explain it. Now, first question, what is the first question? You can see partial pressure of benzene. So, you know that partial pressure of benzene will have a formula, pure pressure of benzene into mole fraction of benzene, yes or no? And partial pressure of toluene will have a formula, pure pressure of toluene into mole fraction of toluene. Now you can see from the question, this is given in the question, this is also given in the question. All we need to do is to calculate mole fraction of benzene as well as toluene first. So mole fraction of benzene will have a formula, number of moles of benzene upon number of moles of benzene plus number of moles of toluene. Now we need to calculate number of moles of benzene, that is given mass upon molar mass. Okay. Now given mass is 7.8. Can you calculate the molar mass of benzene? Please do let me know. Can you calculate the molar mass of benzene? Yes. C6H6 is the chemical formula. So according to that formula, please let me know the molar mass of benzene. Yes, you should remember from 1 to 20 at least. Yes, 12 it is. C has a atomic mass 12 and hydrogen has a atomic mass 1. So please let 78. So you are going to put the 78 and remove this decimal. So it will be 1 by 10, which will have 0.1 mole. In the same way, number of moles of toluene given mass upon molar mass. Given mass is 9.2. Calculate molar mass of toluene. Darshan, is there any answer? Darshan, are you there? Darshan, please do respond. No, it's wrong. It has a formula. C
Total carbon you can see 7 carbon, so 12 into 7 plus 8 hydrogen, 5 plus 3, so 1 into 8, so it will be 84 plus 8, that will have a value 92 gram. So if you are going to calculate it, so it will also have a value 1 by 10, that means 0.1 mole. Now just going to put the value and you will get your answer in here. Mole fraction of benzene will have a value 0.1. Mole of benzene 0.1 plus 0.1, that will have a value 0.1 upon 0.2. Decimal will be cancelled by decimal and it will have a value 1 by 2 mole fraction of benzene. Now I can easily calculate this. Pb will be P naught B, which has a value 400, and mole fraction of B benzene is 1 by 2. So the partial pressure of benzene will have a value 200 mm Hg. Can you calculate this part? Yes or no? Darshan, are you there? Can you solve the next one? Yes. Yes. Yes.